I'll fix it. Okay, I think this is class number 10.
Yep.
Class number 10. What I want to do in class number 10 is let me do share my, let me share my screen. Let's see here. Yeah, I like how the Google Hangout makes it so easy to do that infinity thing. So you guys should be able to see me surf around in Google. Oh yeah, I already pulled up a page here. So I suspect this is a full list of all the Java keywords. It probably is. If there's a couple more, I don't know. You probably don't need them because they're not that important probably, but you'll run into something and you'll be like, oh, I can add that. There's some of these keywords that we've gone over and others that we haven't. Let's go down the list. We'll identify what the keywords that we have not dealt with and the ones we might want to have questions with. Basically, if you think about it, this entire language is made up of 50 words. If you had to memorize 50 French words and say you've mastered a foreign language, wouldn't that be cool? That's about what this situation is we have 50 words. So let's talk about this out loud here. You got the keyword abstract. We have not talked about this, right? Is that correct?
No.
No, we don't know about the word abstract.
Nope.
We also don't know what the word assert does, do we? Okay, we'll go back and look at we're just going to quickly go down the list and see how many of these we really do know. And then we're going to go back and talk about the ones we don't know, okay? Here's Boolean. We've talked about Boolean?
I think so.
Yeah, we've definitely talked about Boolean.
You gotta know the answer to that.
Yeah. We've definitely talked about Boolean.
We've talked about break, haven't we? Talked about break?
I believe so.
I don't remember, but probably if he
Yeah,
says.
that was
okay. We're gonna go back down the list.
Page 127 through 136.
Yeah, I know, but I mean, a Will Ricking example and how it works. Byte? Did we talk about byte?
I know what a byte is.
At the beginning, yes, we did.
Okay, it's a data type. That's all. Oh, I did a byte array. I think I did. We talked about switch case. Switch case was one of our favorite little things, wasn't it?
Yeah.
Because it allowed us to do all those light bulb things. Try, catch, and finally. Oh, we didn't do any of that. Okay, so char. We know char, right?
Mm-hmm.
Class. So we started with that one.
Yeah.
Continue.
No.
That was with break, right? It was like break and continue.
Yeah, break and continue. They work as a pair. Default.
Okay.
Oh, I don't know why you would use this, but I know I was using the switch case. I just don't know why it would be here in a method. Okay, we might learn both. We might all learn a little something here on some of these when we're doing it. We know about the do while. We know about that, right? The do part of do while. Then there's the while by itself. We'll get to that. There's double. We've talked about double. Look at that. We're halfway through the list, and we've actually done quite a bit of these. If, then, else. We know about if and else. I introduced you to enums, I think, last class. An enum. Remember, I said enum, and I enumerated all the different colors of the light bulb.
Yeah, I think so.
And remember how we iterated through the first element enum. This is value 0, 1, 2, and 3, right? And
it's like arrays, but
right, and we use an array to enumerate through the enum. Isn't that neat? You know what the word enumerate means? It means to count. And so it's no surprise that an enum is basically a list that has consecutive values where you can type in a word to represent a number. So this A and this enum in this case represents the word number 0, and this one means 1, this means 2, and that's 3. It's no surprise how they do that. There's an extends. We have not gone over extends. Final. We have talked about final, like you'd use with the number pi, right? Float. We've talked about floats. For. We've talked about for. We have not talked about implements. Okay. Import. We know all about import. Here's instance of, or if I can get that to go away if I do that. Nope. Instance of, we have not done instance of. There's int, which we have done. Interface, which we have not done. Long, which we easily could understand because it's all it is a higher precision double or float. Native, we have not done native. New, we definitely done new. That's how you instantiate a new class. Package, we talked a little bit about packages. Private, we know about that. Protected, we know about that. Public, we talked about that. Return, we've talked about that. Short is another number type that's real small. It's a real small number type. It's only up to the value 512, I think. Static, we know about static. We've seen an example of that. This one I've never seen before, this strict FP, and it's apparently for making it compatible floating point numbers between multiple languages, which I've never used this. Super, we've never talked about super. Synchronize, haven't done that. This, we have not done that. Throw, we have not done that. Throws, we have not done that. Transient, I've never used this keyword either, and we've not used that. Void, we have done that. And volatile, we have not. While, we have. Go to, we never will use. And const, that we use that as part of the pi example, final const. So out of this entire list, you see that we said we did go over it quite a bit. Would you guys agree to that?
Yeah.
So out of 50 keywords, we have really hit much of the, and now when I say that is the entire language, I'm telling you that's the whole thing. The only thing left, these are called reserved keywords. The only thing left in the language is the structure, the curly braces, the parentheses, and the semicolons, and that's all that's left of the language. And once you have mastered the structure, the format that things have to be in, then you can write whatever program you want to do whatever you need to do. Okay. So let's just go down the list here and talk about a few of these that we have not talked about before, so we can add them to our list of goodies. Here's the abstract keyword. Now, abstract keyword here is used to implement the abstraction in Java. It's a method which does not have a method definition, but must be declared. It must be declared as abstract, and the class containing it must be declared as abstract. So you cannot instantiate an abstract class, but abstract methods must be implemented in the subclass. Anybody want to give me an idea about what that might mean? Any part of the sentence, any part of one of those sentences, so we can start unraveling the conversation and the words of computer science.
So is it something that's not related to our program, like it's abstract?
That is kind of right. So
Okay.
what an abstract methods are primarily used for is, let's say you made a class. Everybody familiar when I say you make a class, you know what I'm talking about.
Yeah.
Like a light bulb.
Yeah.
You're making a thing. And you say, whoever makes a kind of me has to implement this method. So give me an example in life where you could, you're the thing. You don't define, you're not interested, you're not going to define the behavior of something, but you're saying anybody that borrows me has to implement that thing. I'm just thinking randomly here. I'm thinking in the area of possibly safety things, like let's say we think about a gun, okay? And we decide that all guns must have a what? All guns have to have a
Safety.
a
Yeah.
what?
Safety.
Safety's okay.
A safety.
Yeah, but that's not true today. But
Okay. Like
give me something that all guns have, but they might be different
A
between
trigger?
gun to gun. Okay. In the world of gun triggers, there are all kinds of triggers, if you did not know. And all triggers are not the same, if you did not know that.
Yeah.
Okay? So there are, you know, tension spring type, there are levered types, there are the kind where they have a safety latch in there that has to be pressed down before the trigger can be pulled. Let's just say that there's all kinds of triggers, okay? So if you were a gun and you're saying, I am gun, right? So anybody that wants to be a gun has to define what kind of gun they are, and they have to implement the behavior of their trigger. So if I want to make it to where I say, if somebody is going to borrow all of my functionality and I'm going to make them implement the functionality of a trigger, okay? You could do that with the word abstract. So anybody that basically made an instance of you would be forced to implement it. The Java won't even compile until they are finished defining their own thing. Now it could be they can make it very easily and they can do it very poorly. That's up to them. But at least what you've done is you force them to actually implement it. Okay.
So maybe this doesn't make any sense, but since a gun already kind of comes with a trigger, why would they need to implement it? Like, is there a reason to
all
leave the
guns
trigger on?
all guns have triggers?
If we pretend that all guns have triggers.
Yeah, that's only if we pretend. But so if I was trying to say, if I was trying to write an abstract class to say, you know, I'm going to allow these 5 different engineering groups in our country or in our company to build whatever they want for guns, but I do not want any guns coming out of this shop without a trigger. Okay, you guys could be creative. You know, I don't want any ball peen hammer solutions. I don't want any. You know, spring-driven flip switches. I want a trigger. You know what I'm saying? I don't want
Yeah,
any
okay.
remote control robot hidden in it. I don't want that stuff. I'm saying they have to have a trigger.
Okay.
Now, of course, this is all theory in software and stuff, but basically, if you're saying, hey, you know, I know there's other types of guns in the world, but the gun that I'm defining has triggers.
Okay, that makes sense.
Yeah, so that's where you would use the word abstract. Basically, what it would allow is the code to compile, and anybody that borrowed your definition of what a gun is supposed to be would be forced to, by the language, implement the behavior that you've defined. So let's reread this thing and see if it makes sense. Abstract is a keyword which is used to implement the abstraction in Java. So what does it mean to be abstract in a real life world scenario? Give me a definition of abstract.
Isn't an abstraction different?
It's kind of like let's say an abstraction is a mimic of something else or a copy of something else. So like your children are an abstraction of their parents. Okay. Let's see if Webster's got a better definition here. Okay, what does it mean to be abstract here? Existing in thought or as an idea, but not having a physical or concrete existence. Well, that's true too. So, this is what I'm talking about, this adjective. So, have you ever heard somebody saying that's kind of an abstract idea? Theoretical. Basically a model or an idea. Do we got the idea here?
I
Yeah.
think so.
Yeah, let's see if there's a better way to define it here. What is abstract thinking? Let's see, get an example here. I don't know. Anyways, let's get back to this. Let's see. Assert. So assert is used for basically telling is for testing, is for putting tests on the inside of your code, and if they don't meet certain requirements, then then during the operation of the program it fails and throws an error out to the user telling them what the problem was. So when you say I assert this thing to be true, if it's not true, then it will execute the fail. So take a look at the assert there on line 11 of their example. Can somebody give me an idea by what I've described and what you see there, what you think assert does? Elijah.
I don't understand the scanner quite, but
Oh, forget that.
I think what it is it's just saying. It sort of looks like a if-then statement.
You're right, it isn't. But it's an if-then statement with a behavior.
It's just saying if something's true or not.
Oh yeah, but it only does stuff if it fails. So what an assert does is it's just like a if-then else statement, but if the problem is if the condition fails, then it does the failing condition. It prints the failing condition to the screen and tells the user there's a problem. So the assert is like an if-then else, and if it fails, then it prints it out to the screen the word fail. Or and where Java is going to have a word that prints out the screen, it's probably going to say something like, you know, in main class main, line 11, assert failed, and it'll have your message fail. Something that'll be fancier, you know, instead of just put the word fail. It'll probably have a whole bunch of other fanciness to help you find out where it is. So basically, in this case, in line 11 there, if marks is greater than 35, it passes. Because that's what you're saying is, I'm saying whatever happens here, marks should, in this case, marks should always be above 35. Let's say, for example, you are measuring you are making a digital thermometer that measures body temperature. Okay? If you know that when if your device is failing, it has a tendency to read like either 0 or some really low temperature value, something that's way out of the range of human body temperature, right? So inside your code, you could say assert temperature greater than 80 degrees Fahrenheit. So that if it does, what it'll do is it'll put this little turn this little red LED on that says that the thermometer is not working correctly. You guys see that?
Yeah.
So it's basically just to tell you if something goes wrong, if something
right.
Isn't.
You intentionally put these little checks in your program to make sure things are running the way that you've designed it. Now, apparently, they have designed this thing to say that this scanner thing, whatever it's scanning, should always have a number greater than 35. I don't know what it's doing either. Okay? We don't know the details on the other side of the code, and it doesn't matter. What our job is to see, do we understand probably what that assert line does on line 11? Okay? You can put an assert in your code just anywhere. Of course, it should have some kind of condition. If you always said assert true equal fail, or colon fail, your assert will always pass because true is always true, right? So that's probably not great. It's probably, and this should the mark or whatever's between here should evaluate to a Boolean operation, to a Boolean true or false. We already know what Boolean is, so we're going to skip that. Break. Basically, you could have, let's say this. Do we understand what break is? Whoever doesn't, let me know. No, so we should talk about it.
I'm not totally sure.
So
okay.
Does it it stops a loop, right?
That's right. It'll break out of an if statement or a for loop. It'll break out of a for or a while loop. So what they're saying here is in the for loop, they're saying I'm going to go through 100 numbers But if the value in this iteration ever equals to 50, then I'm going to break out of it. Now, of course, logically, this doesn't make sense because it'll never get past 50, right? It'll be 50 and it'll break every time. But this could be something else in here, this if statement. This if statement could be, if I still have communication with the server, then it's okay. But if I ever break communication with the server, then I want to break out of this loop and then report an error or something, or stop trying, or, it depends on the context of the program of why you would want to break. But the point is that when there are times when you want, then you said you're in a loop that you seem to not be able to get out of, and this is how you get out of it. In either an error situation or a situation you're looking for or whatever, you're free to do it. I'm not going to give you that. I'm not going to tell you what color to paint your canvas. Okay. The byte here, this is basically just like an int, but it's a smaller type of int. It only handles the numbers right here, -128 to 127. There's a lot, it just takes up less space in memory. Memory is not an issue these days, in most computer systems, but this data type is here. This data type is here so that you can, because there's a lot of times that most of your operations are within these values, and it becomes a convenient data type to use, because you don't want to be any more wasteful with memory and space as you don't have to be. Do you guys don't understand what byte is?
I got it.
You guys get break. Before we had I'm not sure.
Yeah, I've got that.
Okay.
Yeah.
Okay, we've only got 50 keywords and we're already at 6 and 7. We know switch in case. Try, catch, and finally. Okay, so this is like a trio. You could do a try. Usually it's followed by a catch, and the finally is basically finally is done if catch is not. So you can think of all these as a big, now the whole finally block is actually optional. You can just try catch and not do the finally, but if you do a try, you will do a catch. And what a try does is it turns out that when you make a method, you have another command which we have not gone over yet, and it gives you the ability to throw an exception. It's kind of like assert, but it's the kind of assert that you want to communicate to other objects. Okay. Now let's say, for example, give me the type of, let's use an automobile and all their different systems in their car. Give me the kind of error that you do not, and let's say that all the components have the ability to talk to each other, but they have to choose whether or not to talk to each other. The radio, the braking system, the gas pedal, the throttle, the engines, all the engine stuff, the headlights, all the things could talk to each other. Give me an example where you might want to assert a problem, but not necessarily throw a problem. Throw is the idea that you want to let other components know about your scenario. So give me a practical example in an automobile, in a car part, where you might want to do just an assert, and because it's a kind of an error that you don't really care whether other people know about it or not.
Like wiper fluid.
Like wiper fluid. Yeah, why would the braking system care whether or not the wiper fluid was low?
Yeah, because it won't affect it at all.
Won't affect it, and you've communicated to the user with an error. Assert, fluid level below 5%. It throws an assert. Now, the word assert actually, that's really is not designed to be used in code to communicate to the customer. It's used to kind of guard bar against your own design. But we're going to continue with this talk because just to give you the perspective of the try catch here. Now, give me an example in a car where you would want to broadcast something that you think at least one other system would want to know something about.
Like maybe the check engine light?
There you go, check engine light. That might, it would be important because the braking system might have to, it might be challenged with the hydraulic pressure, or the steering, power steering needs to know, because it's also driven by mechanical energy, and there's all kinds of other things. So there is a mechanism in Java programming and in other C++ and also in C#, the ability to throw an exception. Now, you can define an exception, and the thing is about throwing is, if you throw it, then it keeps going up the chain, like the parent caller, the parent caller, the parent caller, until somebody catches it and does something with it. Okay, so it's kind of like playing baseball with code. I throw a problem and I'm just waiting for somebody to catch it. Now, if nobody catches it, it does go all the way to the top level program, and the top level program will catch it by default and complain. Okay? But usually, if you've got a good design, you're catching them way before it gets thrown to the top level. Okay? So in this case, and on line 7 of our example here, it's possible that the integer.parseInteger can throw an exception. And as you can tell by their example, what kind of an exception do you think would be thrown here? Gavin. Did we lose Gavin?
I'm sorry, did you ask for me?
Yeah.
Oh, what?
So we were talking about the ability to be able to throw exceptions, and for some things having, we'll go over the throw part, but right now, when you throw an exception, what you do is you try to have something that will catch it and handle it properly. So in this example here, they are trying an operation which might throw an exception. It turns out that if you don't put try around something that might throw an exception, the exception it throws goes to the top caller of that, and keeps going to the top caller until it gets to the main of the application. Then it gets thrown out by the system. And you'll see it eventually, but it will not necessarily be handled properly, and it might look nasty. So in this example here, what do you think the kind of exception that's thrown on line 7? Why would they put that line of code inside the try block?
They would put it there because it relates to the system outprint, right?
Well, what are they trying to do, you think, on line 7? What are they trying to accomplish in that line of code?
They're trying to run it.
Well, what is that one line of code performing? What operation is it performing?
I'm not sure. I'm sorry.
Okay, so what it's trying to do is it's trying to convert the string ABC into an integer value. How successful is this going to be?
Not very successful.
No.
Also,
Now, if the string was like 503, then it could take the string 503 and convert it to the integer 503. But in this case, it's not going to really know what to do with the string ABC, because it does not parse very well as an integer. So it has defined a special type of exception called a number format exception. And the catch that they have is specifically designed to capture that kind of exception and no other kind of exception. So if it throws an exception other than number format exception, then it will pass it to the parent caller and it will have to handle it there. But this catch is specifically designed to capture a number format exception. If you go into the definition of integer parseInt, you will see that what it will throw is a number format exception. Now, it is a type of exception that is defined by the caller, and the person that's using, excuse me, it's defined by the person that implements it, and anybody that wants to catch that special kind of a special kind of exception, we'll have to do it. And if not, it'll eventually will get caught by somebody. So in this case, what's happening is the person caller recognizes that the input to this parameter may not be friendly as an integer. He's looked up in the documentation and recognizes, well, hey, if I detect a non-friendly input, I'm not going to try to turn ABC into a number. I'm going to throw an exception because the caller is not using me correctly. Because if you look properly here on line 7, it says integer.parseInt, and it really wants you to, yes, it does take a string, and strings can be whatever character you want, but it's really expecting some numbers in there as an integer looking thing. So it says I cannot convert this into an integer, so I'm going to throw an exception. Now I have defined the exception to be a number format exception. So anybody that's interested in calling me can know exactly what I'm complaining about when they try to pass me the letter ABC and turn it into an integer. Okay?
So is an exception like a fail signal?
It is. It's kind of like it's like a complaining message.
Okay. That makes sense.
And it's a complaining message that is designed by the person implementing it. Okay, these can be whatever when you define these exceptions, you can call them whatever you want. What they've called this was a number format exception. It's kind of nice if you name the type of exception to be closely related to what it's actually doing. They could have called the exception 2 ducks in a pond, but the problem is when you're catching 2 ducks in a pond, and what it really is doing is making it to where there's a number formatting error. It doesn't line up with human beings very well. Okay, so they have defined a special type of exception. Now, if they were to put the integer line 7 and line 11, and they were not to put try to put it inside of a try or catch, it still would throw an exception, but it would not be caught at this point. It would be caught at another point. And eventually your standard out would say something about it in some kind of probably nasty unformatted way. Okay, at least when you catch it this way, you have the opportunity to format it and do all kinds of special stuff with it. When the system does it, it's whatever it does. It just dumps it out. It just basically throws it up. Okay. Finally is something that will run if catch is not. So if it's basically something that runs whether it's in try or it really runs in catch. So basically the finally has only done something that if you say no matter what happens, whether it passes or fails, I want this thing to be done anyways before it completely dies on me, because there might be something important, like for example, let's say you were in charge of operating a submarine manual or automatically, and you just might want to, the very last thing you might want to do is to close the hatch just in case you don't want water to come in. So I don't care what fail you have here or stuff. I may not know whether I'm going to go under the water or whether I'm not, but I just want to close the hatch just in case. Because I'd hate for me to, create a big old error and then for them to take a dive move and start filling up the, submarine with water. Something like that logically, but not actually. Hopefully it wouldn't be that, let's say, fragile. But logically, that would be something that you would want to do anyways, regardless of whether it failed or not, as an example. Do we have any questions on the try catch finally? Remember, finally, this is an optional statement, the finally. Okay, gonna move on. We already talked about char.
We'll be the try catch finally in the future.
Well, we very well could. Now, this is something that you kind of do to build kind of debugging and managing things when you're using them. Now, if I were to give you the job of taking a string of 2 different strings and adding them together as if they're integers, and you tried parsing them and you had a fail, you want to fail properly to your caller so that it doesn't, you want to handle things properly. You don't want to crash unnecessarily. So there's things that you do to make sure that you handle things properly, because you have a responsibility when you implement things to handle the errors, do the thing that it says it's designed to do, and then return and get out of it. No crashing allowed. Okay. We went over the character keyword. This is basically, it's a data type that's reserved for a letter of the alphabet. Okay. In this case, it also includes unicharacters, which includes Chinese characters and Greek and everything else, but okay. The class keyword, I doubt very seriously we need to go over this keyword because everything we do starts with the word class. Here's the structure. Now, here's the interesting thing. Ryan, you were saying, well, I keep going into the development environment. I don't know how to start. You should know that everything is a class, and it starts with class, the name of the class, open, close, curly brace, you get yourself some space, and then you can put your method name, method, and recognize the structure, even if it's a cheat sheet, in front of you. Like this is kind of a cheat sheet right here. This structure, you could start with this program, delete the for loop all the way down here, and with these two lines here, this is a requirement for every Java program. Or this includes that curly brace too. You could delete what I have highlighted there, and that is the beginning of every Java program. But it turns out that if you go into NetBeans, you say, I want to make a new project, it just does this for you, if you noticed. Okay. The continue keyword is kind of opposite of the break. Okay.
Wait, so why would you need to continue if breaks only are in loops? So if it's looping, then why would you need to continue it?
Well, let's take a look at this. So if we got 0, it's obviously going to go from 0 to 99 here, right? The for loop. So 0 mod 5 is it not equal to 0? Remember the mod function, it's divide, but we only care about the remainder. So 0 divided by 5, what's the remainder? Elijah.
0 divided by 5.
0 divided by 5, what's the remainder?
Oh dear. That's a weird question. You're not gonna have one, I don't think.
How many times does 5 go into 0?
0 times.
Yeah, well, it turns out the remainder is 5.
Okay, I see what you mean.
Okay, so is 5 not equal to 0?
No, it's not.
Yes. Yeah, 5 is not equal to 0. That's true. This is not equals, by the way. Not equal. So is 5 not equal to 0? Just listen to the English.
Yes.
Yes. So then we're going to want to continue.
Oh, okay. So I see what that means. So if it's not equal to it, then you want to keep going until you get it equal.
So it'll continue. Now, the other interesting thing, though, is this doesn't make a lot of sense because without there being a break for another condition, the continue does not make sense. It is very strange, I will give you this. It is very strange to have a scenario where you want to use the word continue, but it is there for your disposal, okay? There are some of these keywords that you may never use. Continue may be one of those. Auto will be another one, and go to will probably be another one. So there's already a handful of keywords that you will never use because there's so many other cooler ways to solve the same problem, okay? Just because there's 50 keywords doesn't mean you need to have the whole thing. If I told you there was 50 French words in the entire French language, you can probably even realize that you need to use all 50 words to be able to go to the bathroom and eat your dinner. It's that kind of a logic. Okay, so default is another one. This is another one you probably will never use. Default keywords used to define the default methods in an interface. What does that mean? I know what default means in the switch case statement. Remember that? In the switch case, default is the condition when it doesn't meet any of the other switch or any of the other cases. like you had case 1, 2, 3, 4, 5, 6, but then you get the number in there and it's not any of those, then it goes and does the default. If not, then it would skip through if you didn't define the default. But using default here in this case, I have no idea what it's used for. Default keyword is also used. I know it's also used there. This is how I know it's used. Default keyword is used to define the default method. What do they mean by default method? You have to call it. So you have to call methods to use them. So I don't know what makes it a default. This is worth maybe looking into further. But I've never used, I'll put it this way, I've never used the word default in the context that it's showing here. But I have used default in the switch case statement. Okay. You know, and like you don't, there's not an obligation to know and all of the details and every keyword and everything to be an effective programmer. That's kind of like being an artist and you are not familiar with a certain kind of a brush and somehow you feel like been an inferior painter because even though you've been doing it for 30 years, you didn't know about this kind of brush. You know, it doesn't make any sense. We know about the do. The do is special in the sense that it always will perform this loop at least once. You'll always do it once and then check. And sometimes it's necessary to make sure that you do something at least once, because there's a lot of cases in here it'll do it once and then get out of it, whatever. But sometimes it has to repeat. That's on the condition of the while. This turns into a Boolean operation. If A is less than or equal to 100, it's true. And if it's true, it runs it again. And it keeps doing it until this is not true. It is possible in these do whiles here to have a condition. Let's say, for example, you forget to increment the letter A, and it's true. Guess what it's going to do? It's going to run this do forever and ever and ever and ever, and it'll never get out. So you got to make sure when you're doing these while loops and things like that you can actually get out someday. The double keyword is a special way of indicating floating point numbers. We've done this before, you know. There's times when you want to have a number being precise other than just an integer. We know about if then else. We've done plenty of that. There's if condition and else is optional, right? Just like the finally. The else is optional with the if statement. You can have just an if statement all by itself, or you can have an if else combination. Else you cannot write by yourself. So it's you can do if or if else, but not just else. There's no such thing as an else by itself, because there's no elsing to whatever it's doing. So there's just no else by itself. Somebody needs to stop me if I think that there are things that we are not understanding that I think we are understanding. Okay. We did quickly go over enums. We'll be ending the class here soon. You guys need to take a break?
I'm good, but
Okay.
Okay, good. And we'll just blaze out until the end here. I quickly went over the idea of an enum. What it is basically it's a list of numbers that are given a name. This number is always 0. This one's always 1. This one's always 2. This one's always 3. And the reason it is because in the order that when they're listed in the enum. So enums is basically a named number. And there's times when you want to use that just for readability purposes or to make sure that things are all listed. A lot of times enum is used for let's say, for example, you want to list all the types of errors that your system can have. You know, light bulb missing, turn signal broken, brake system out, whatever, all the, so you want to define all of the types of errors in your system because you don't want somebody to mislabel an error and it not
so
be.
it basically just, sorry.
Kick on.
Oh, so it basically allows you to like name your numbers?
Yeah, so this is like having a list of 0, 1, 2, and 3 in a list, but now you can refer to them by name. My enum.a
can you
is
does A always have to be A, or can you name A something else?
No, I called this one white, this one blue, this one green. Remember, I did an enum with.
Oh yeah.
I think I did an enum. Let's see if I did an enum. I am pretty sure I did. I probably did it on my light bulb here. I did an array here. And I'm pretty sure I did an enums. Did I do an enum? Well, in this case, I didn't. But either one of your guys' I did or that. But basically, somewhere in here, I think it was somebody. Oh, what did I do here? K0. Oh, random num colors. Okay, so in this case, I did an array of integers, or an array of strings. But anyways, I did something like enum color. I could do, I think I did something like this: white, green, blue, red. I like to make my enum inside here all caps too. I just do. Now, when you refer to this enum, you can literally say color dot blue. This literally watch. Oh, let's see if we could actually do this. I never tried this. I'm going to go out on the limb here and see if I can do this. It might complain. But let's see if we can we'll say inside the constructor. So when it's first done, let's see, what if I say, is it console? Oh, system. System dot out dot print line. The value of 3 plus 2 is, and I'm going to say 3 plus color dot. Oh, it won't let me. Oh, do I got to do? Oh wait. Oh, I got to do plus. Oh, I think it's going to let me. Okay. I think this is going to be. This is going to print the right answer. Let's see if that's true. I mean, this is not how you'd normally do this. You know what I'm saying? But oh, it's 3 blue. Look at that. That's not what I expected. Wonder if I can cast this to an int. Wonder if it even understands an int like that. Like integer dot. Oh. I think it's just a matter of it. I don't know. I did not expect that. But inside your program, though, you can think of them as a number because they're used in the iterative processes and a way of but basically it's a way of listing a bunch of stuff, and there's no duplicates in here, and they are all assigned a value and a place. Okay. That's the point. That's the point of the enums. Okay. I totally tried to misuse it there, and it didn't work out so well. Extends is when you develop a superclass and you might have a subclass. I've already given an example of a potential superclass. Can you guys remember what that might be? I didn't call it a superclass when I said it. It was gun. So if I were to say and define that a gun is a certain thing, that would be the superclass. So if you were to say, want to make a class called handgun, for example, or a 9mm Smith & Wesson extends gun, then basically you're saying that my 9mm Smith & Wesson carries all the characteristics of this gun definition. You guys get that?
Yeah.
Then it turns out that anything that you extend, you automatically get all of the methods that your superclass has already implemented. You get them for free, as if you define them yourself, or you can redefine them yourself locally. And sometimes the superclass will force you to implement certain functionality just because you're extending them. So, for example, I might have a light bulb class, and if somebody said, class of refrigerator light extends light bulb. Okay, then my refrigerator light bulb, which is a special utility light bulb, it gets all the characteristics of a light bulb at the parent, which means it doesn't have to worry about how to turn on and off. It doesn't have to worry about keeping track of its state. It gets all the functionality that a light bulb gets, except that it has to implement a new function for managing temperature because it's got to do something because it lives in a cold environment. Get the idea of that?
Yeah.
Okay, so final, we've already gone over final, which means it's like a constant, right? It means it cannot be changed, and the compiler enforces that. Float is just like double. It's just a different range of floating point, how much precision it gets. Turns out a double can go up further. And there's a for loop. We've already talked about this. This is used for iterating, and iterating happens a lot in programming because sometimes you want to keep testing something or run something through. So when you're talking about interfaces, for example, actually I need to back up because the gun was actually an abstract interface. So you would actually implement a gun, and extends would be more like, well, the same kind of logic, except that would be, instead of it being defined as abstract, it would be a gun that had methods. That's really the only difference. If it's a class that has a bunch of abstracts in there, then then it's implements. And if it's a class that has functionality, then it's extends. Now up here, if you look in the abstract again, it said abstract keyword used to implement the abstract part. The method, a method which does not have method definitions, must be declared as abstract, and the class containing it must be declared as abstract. Basically, it's a definition of a bunch of classes and methods that have no functionality. Well, in that case, you extend it because it's a special type of class. And in the kind of class that actually has functionality that you get for free, that's extends. As you start to become familiar with it, you'll distinguish that difference, I guess. Let's see, we know about the imports. It brings in a library functionality for us. We've done this quite a bit. One of them is done for us automatically. If we wanted new things like our random number thing, required us to import Java util random. The reason we know that is because when we tried using it, it complained, and then we wanted that functionality. So our development IDE actually told us the answer to that. Instance of is used to check whether an object is of specified type. The syntax for using it is object reference instance of type. What it does is it's a Boolean check to verify a relationship between two things. But I don't think I've ever used that. There might be another one of those that you'll never use. But of course, you might run into a situation and be like, oh, maybe this is where instance of is. Int, we know about ints. Interface, this is the interface class. Oh, excuse me. So the abstract is extends, and the interface classes are the ones that are implements. So when you're implementing an interface, and all an interface does is defines the methods that you have to that your object has to do. So there's interfaces and abstracts are very closely related in the sense that how they're the kind of functionality that's passed to the next thing. Likely you're not going to be doing this interfaces or abstracts for a little while. Long is another type of data type that's it is actually a bigger int. Now they do have, remember, they have an infinite precision integer, but it's a different kind of class. But for a built-in type, this is a long, which is a number that can be an integer type, but it can be a much larger than an int. And I think an int can go to like, I don't know, a couple billion value before it runs out of its ability to record itself. So it has to be a pretty large number for long to step in. The native keyword is used when the method with a method to indicate that a particular method is implemented in native code using the native interfaces. This is used specifically for when you're trying to interface with other languages. Like, for example, it is possible to compile code in another language and provide an interface for it, and Java actually gets to call into that executable or binary and be able to execute, send messages to it and have it execute things on its behalf. I've tried doing this and I haven't finished an implementation with native, but so it's not used that often. If you usually need to implement something, you just implement it yourself. But I've never run across a situation where it's only been available in another language and I've had to sneak into it and figure out how to call it. The new keyword, we know about this. That's for making an instance of an object. Like this could be our light bulb object, and this gives us our remote control to that object, our own personal version of it. This is saying light bulb, my light bulb equals new light bulb, right? Or any other kind of class that we've defined. Package, we talked about packaging. We haven't been using packaging at this point, but our package is very simple in this, in that it's basically called light bulb example, but the typical packaging in Java is dot notated, and every dot means a directory level change. It's a way to organize your code solutions into different directories in a standard way so that other Java developers know how to find your stuff. So for example, if they use functionality that's in lightbulb example.example.myexample, then if they really want to go down the code and see what it was, they would know exactly how to get there because each one of those is a directory. Talked about private and protected and public. Return for sure, short. Static means that it means there's only one copy of it. That means there's only one instance of this declaration, which means that if somebody else tried to create reference to the static field, they wouldn't get their own copy. They would get the one copy that's defined in the world. It means at times everybody talks about this static field. They get reference to the same one, so they'll all get the value 555 instead of starting over. It's basically almost like a global variable or a variable that sticks around so that everybody can borrow it. This is another strict FP thing. That's not even worth talking about. I've never seen it used, and I have never used it, but I doubt very seriously you'll ever need to make sure that your floating points are, neutral between different environments. If you start getting that kind of crazy calculation where you need to be careful about that kind of stuff, you're going to know probably all about that stuff. Super means that you're wanting to talk to the parent. So the superclass, the subclass. Your parents are the superclass, you're the subclass. If you called super 10, you're basically saying, I want my parents to do it, please. But if you're calling yourself, then you're saying, I want to do with it. So this super 10 actually calls the constructor of this. And the reason you're allowed to call your parent is because you extend from your parent. Does that make sense?
Yes.
So, okay, you extend from your parent, and with the word super, you have the ability to ask your parents to do a whole bunch of stuff for you. Now, that's interesting because in real life, you don't get that. You don't get a super class, do you?
I wish.
So here's how you can pull this super class thing is you can have, let's say your mom say you need to take out the trash. And what you need to do is then call super on trash and have your dad do it. Okay? So I don't know if he's going to buy into this whole super thing, but it works in programming. Synchronized is necessary when you're trying to make sure that things happen in a very certain order. This happens a lot when you're talking about network communication and communication between two computers over a long distance or something. And you want to make sure that those two things remain in synchronized, things that come in a synchronized way. And you want to make sure that when you send them out, it's all synchronized when it goes out. So there are some scenarios where that if you don't do something about it, it's going to get screwed up. And this is a way to tell it that it is that all this stuff is synchronized in here. So that any thread which calls and wants to order this method must require a lock to get these methods. So basically, it says, can you imagine that both you and your parents, you and your dad, both want to take out the trash at the same time? And so if you both try to take out the same can at the same time, there's going to be a problem because one person's got their hands on it already. And so this kind of thing happens in programming. And what this will do basically is before you can take out this other trash, you need to make sure that you're clear. So it basically waits here until it's your turn to take out the trash. Or bowling, for example. You don't want two people to go up to throw a ball down the aisle until it's your turn. So it's a synchronized event. You know, there's certain things that lend itself to needing to be synchronized. Now, the this call, there's a this. This can be used in a lot of different ways. This and this way actually calls your constructor. It calls yourself. It's kind of like super, but it's you telling yourself. So this one calls a statement to the first constructor, which is this one right here, because it has no parameters. So you're basically saying this, and when you're saying this, you're referring to the class. Just like when you talked about super, you're talking about the class. But in this case, you're talking about the super class, which is A. So super and this are kind of related in a way. Here's that throw and throws. So throw is the actual act of throwing the exception. Remember we talked earlier about try and catch? Well, here's one where this try, when it does something, it actually throws another exception. And in this case, this exception catches this catch catches this exception. Now it is, but theoretically, let's say, for example, it's really your caller, the thing that you're calling, for example, trying to convert that string ABC into a number would throw this number exception, not just throwing it right here in the try. So it would throw the exception, and that's what would actually logically be done at this point if you try to convert ABC into a number, and then this would catch it. Now in this case, exception, this one catches all exceptions. When you just have the word exception, it catches all exceptions. The one in the other example specifically was only looking for number format exceptions, and it would ignore all other kinds of exceptions. But when it has the word exception here, it means it's willing to catch any exception, which includes this one, by the way. Then we have throws, that's with an S. And what you're saying here, to specify the exceptions within the current that it may throw it. And I'm not even sure the usage of this, because it seems redundant, as I don't know that it would do, I don't know if it would provide you any value. So let's say, for example, we know that this could throw an exception. Well, if you know that it should throw an exception, you really should wrap it with a try and catch the exception. So why would you want to tell your method that it throws an exception? I don't know here. I'd have to dig in more than this. There's obviously more here. This is a little interesting, but not too much. See, it says it has more here. Throws, okay. Oh, I know what it is. Yeah. Oh, this is actually defining a behavior for the exception itself. It's basically saying it's going to throw this type, which is defined no pointer exception, and this is going to be the message that it sends. So basically, it's telling the try the type of exceptions that it throws, and then over here in your catch, you can catch that kind of exception. Anyways, when you start getting into the implementation of tries and catch and throws, you can look in the details and see. We've talked about, oh, there's a transient. It's interesting here. There's another keyword that I've never used before. This one's saying that the transient keyword is used in serialization, but however, which is declaring it, but things that are declared transient will not be eligible for serializing. So, for example, if you wanted to make it to where you say, I don't want anybody to be able to serialize this thing, you're going to put the word transient here. And so if you try to serialize it, it will complain.
Remind me what you mean by serializing.
Oh, we didn't go over serial. Did we go over serializing?
Maybe.
No.
Serializing something is making sure that it comes in order. So, for example, if I were to tell you that if I had a method that I'm going to tell you the letters of the alphabet, there are several solutions to that answer, right? I can give you, you as expect 26 different letters, but I did not promise you any particular order. Did I?
So isn't that the point of synchronizing though?
No, synchronizing is having two things work together.
Oh, okay. So it's only two things though.
Yeah. But when you serialize, do we have the word serialize? Where is the serialize not a word? Do we skip over serialized? I thought serialized was a key word, actually. That's a little strange. I think they skipped a key word. For some other kind of, let's see. Oh, that's why. See, it's not a native type. You have to dig into the library to get it. So the keywords, the 50 keywords that I'm using, that means you don't have to, none of those 50 words you have to dig into the library to get. They're right on the top. They're right on the top level of the language for you to use. They're the things that define it. All this other stuff is digging into the libraries. Okay, remember all like the random? Like all that other stuff in the library is huge. Well, it turns out you to make something serialized, then you are going to have to call it within the library. So this is interesting that they would have a top level command that is somehow related to something you have to dig into the library for. There might have been a little mistake there in the architecture. They probably should have brought serializable up to the top, but they probably, when they were designing the language, they probably forgot, and they said, well, here's a solution. Because it probably turns out to be the same thing. So what they're saying is that when you're filling out a well, I don't see how that's stopping any serialization. That's not really a good serialization problem. Let me see if they got a good serialization problem here.
Problems with your computer, because for the past 20 minutes your screen has been frozen on me, and you keep going out.
Is that true for everybody else?
No, it's been good for me.
Okay, so I think it's your bandwidth here.
Oh well, we get 2 kilobits per second.
Okay. Well, anyway, serialization is, I'm going to say in short, is I can make one problem saying I'm going to go. You can't? I said one problem that I could say for serialization is I could say I could give you back 26 letters of the alphabet. Now that commitment does not give them in any particular order. But if you were concerned about the order, then let's say I had to go to 26 different people to get the answers to my alphabet. Okay? Let's just imagine this is a kind of a, you wouldn't imagine that problem being real, but let's say my job was to give Ryan the 26 letters of the alphabet. So I went to my 26 different neighbors, and they gave me the alphabet. But depending on what order I saw those neighbors, and depending on what letter they have, I may not give Ryan the 26 letters in the order he expects. Now, if I was obligated to serialize them in a particular way, then I would have the additional job of making sure they were sorted before I gave them to him. Well, the serialization thing kind of does that kind of thing for your code. There are cases where you need to serialize things. For example, if you are communicating a web page to a client, you do not want the HTML to come out of order. Can you guys appreciate that?
Yeah, so if it's not a keyword, are we actually able to do that?
Well, the keywords are keywords in the sense that you do not need to dig into the libraries to get them, but you still have access to everything in the libraries.
Okay.
This is not the end of the language. This is just the end of the keywords. I think, I haven't looked into it, but I think they made a mistake between synchronized and between transient and serialized. I'm going to have to dig into this further. I've never used this keyword, so I've never seen a scenario that's needed this. So I've already identified probably 5 to 10 things that I say I've never done in this language. I've been successful in this language. So just telling you, there's times where, like, there's a keyword in C called auto. By default, all data types by default are auto type. So why would you declare auto in front of them when it makes no change and no difference for anything? So nobody ever did. And there was a keyword in C that was never used because it had no actual value when it was designed in the language. But unfortunately, what they've done is they've taken that auto keyword, and in the newer versions of C++, they've given it a special function, which is very interesting. It means that basically it auto types itself, and it's actually pretty powerful. Let's see. So void, we know about voids when something is not expected to or not obligated to return anything. That's what void means. That means I am not going to, and I am not obligated to return anything. Volatile. That's another one of those keywords you're probably never going to use, because this is a little bit about memory management. And in Java, you really don't need to worry about the memory. It kind of does it for you. While, we definitely know what while is. While is a very powerful, well used. So there's while.
I'm just gonna let you. I'm just gonna let you know that
Yes.
if you quiz me on something, I might not know it because you've been freezing for the past 20 minutes. Like,
Okay. And it might be good for you to go back on the link and look at the last 20 minutes. Watch the last 20 minutes of the thing, because I'm talking about the rest of the keywords and their functionality.
Okay.
So just go back and watch the last 20 minutes of the video where you think you're been off, because and I am holding you guys to stop me if you're not catching on, but I'm not trying to put a lot of emphasis on these either, because a lot of these keywords are simply not used, and until you get into a very, very specific scenario. And by the time you get in those kind of scenarios, you've been a little familiar with the language, and sometimes there's these little corner things that you need to figure out because you're in a very special precarious situation. And if you don't get into those situations, or you don't get into them very often, then that information just goes away from you. Okay, so there's while. We know about the while keyword. And then we got goto. Goto is specifically a direct jump. Gotos are known to be very bug-ridden and very dangerous, so nobody ever uses goto. To literally say go to some other place, some other, I'm not even sure what the limits are. Is it line? It's not the line code. Oh, I know what it is you declare labels. So you type a word and put a colon after it, and it defines a label, and then you can say go to, and you just jump to whatever label. Just don't ever use gotos ever. They're so prone to being bug-ridden that people just don't. And it turns out that not one good programming paradigm uses goto in there. They specifically tell you to not. Constant is something we used in the example for pi, because it's something that is a constant value. It does not change. And there you go. That's all 50 keywords that is at least professed on this page, and that's probably all of them. So, in short, we have basically explored the majority of the language. Everything else in the language is really digging into the special functionality and libraries that come with it, finding examples on other people are doing and understanding what those examples are. I think as a homework assignment, what I'd like you to do is to find a couple of simple examples on the web. Something probably a little bit more interesting than Hello World, but something that doesn't have too many lines of code. Maybe something that has 20 to 50 lines of code, no more than 50 for sure. And being able to unravel what every line of code does. And if you have small programs, then you're gonna have to do like 2 or 3 of them. But if the total number of lines of code is between 30 and 50, that's what I want. So if it's 3 small ones or 1 big one, but some combination that's between 30 to 50 lines of code, and for you next week to be able to explain every character and every line of code is doing in that example. Now, if you do multiple examples, don't do multiple examples where it's got a lot of the same, like it's 3 versions of the same thing. That's no good. Okay? So some small little short example, and you may very well find a example on the web where they explain line by line what it's doing. And I don't want you to read it, what it's doing line for line, but I want you to find it, read it for yourself, understand what you've read, think about it on the line, so that you can demonstrate it in the next class saying, okay, this line is opening the code block, and this line is assigning the variable or the integer value to this. This is calling this method. This is getting a random number from this. This is doing the modulus division, and it's going, once it's equal to 5, then it's going to break the loop, and it's just walk through it just a little bit. You know what I'm saying? Just to, I want to, I don't want to, I want to hear what the lines of code are doing. Does that scare anybody?
Me?
Okay, well, it's time, Gavin. It's time. But try it. And you might be best looking for maybe even search for a Java line by line example explanation. Maybe that's your Google search, right?
Yeah.
And what I'm going to do is accomplish 2 things. One, I'm going to teach you how to teach yourself. And number 2, I'm going to make sure that you can explain it. So you literally can get the answer from somebody else on the internet. But you should not. So I was explaining to Ryan before you guys got on, I said there's 3 things. There's 3 things that you should worry about in life, or 3 things that you should be aware of in your life. The things that you know, the things that you don't know, and you should be really afraid of things that you don't know that you don't know. Okay? So what that means is it would be good for you to recognize in every line of code, you should recognize, I know that I know this. Or you should look at the line and you say, I know that I don't know this. But you should not look at a line of code with complete blank mystery of I don't know what I don't know. That should scare you. Okay? Is that fair?
Yep. Could you actually send us a link of the 50 keywords?
Yeah, that'd be nice.
Yeah, that'd be really helpful.
You think it would help you? Okay, I just basically found one on the internet.
Oh, that looks really good.
I think I can. There you go. Look in your chat message, and everybody that wants it gets it. Okay.
Okay. Thank you.
Yeah. So if you want it, get it now. It will probably not be available in the broadcast because I don't think you see chat in the broadcast.
No.
Okay, so share with me your last bit of thoughts before we end of the day. I can already feel Gavin shaking in his boots. Is that correct, Gavin?
I'm sorry, I didn't hear.
I said I can already feel you shaking in your boots.
Well, I guess so.
Okay, but you're going to do this, right? You can tackle this. I mean, it's a pretty straightforward assignment. I'm not asking you to unravel mysteries here. I'm asking you to find something where you can put the answers right in front of your face. Because what this will do is give you an example of how do I learn? How do I learn by myself? How do I, how do I find information out? And so I want you to, there really is a difference between, physically participating and mentally participating. And there is a difference between reading for comprehension versus reading to get the syllables out for everybody else, right? And as far as I know, all 3 of you guys are college bound. And when you go to college, you need to learn how to read to get the information out of the material because it's not enough to hear the syllables. Okay? So that's what I'm asking you to do with this project, is I'm asking you to find, either you're already enabled enough where you can get an example and you can explain every line of code, and that would be great. But if you cannot do that, then get some example where it explains it. Either it explains it so that you can explain another example or explain the same example you found. That's fine either way. Now, what I don't want to see is explaining your example while you're reading the explanation to me, because I don't need to hear the syllables. Right? Is that fair? So what I expect is you to be able to free form answer questions and answer without reciting. And I'm only asking for a small example, right? Something like 30 lines of code. That includes curly braces and everything. And if it doesn't exactly equal 30, that's okay. But it should be, you know, it should be a light bulb size example. Or 2 examples that add up to a light bulb. But you will find plenty of examples on the internet. Okay?
All right.
Okay. Then that's
Right.
about it for us. I'm going to stop the broadcast.